Consider the 638 Newton weight held by two cables shown below. The left-hand cable had tension T and makes an angle of theta with the wall. The right-hand cable had tension 800 newtons and makes an angle of 35 degrees with the ceiling. What is the tension T in the left-hand cable slanted at an angle of theta with respect to the wall? What is the angle theta which the left-hand cable makes with respect to the wall? Okay, we have here our system which is in equilibrium. We're going to draw a free body diagram. So we have weight, and we have tension 1, and then we have tension 2. I want to define all of my vectors with respect to the positive x-axis if at all possible. So remember, here's the x-axis, so we want to always go positive x-axis counterclockwise. So we will define all of these with respect to the positive x-axis counterclockwise. And we're going to call each angle theta, whatever the vector is called. So here we go. Here's our givens, and we're given that the weight is going to be equal to 638 newtons, and from our diagram it's at 270 degrees. And then T1 is going to be equal to 800 newtons at 35 degrees. Now let me show you why it's 35. If you come up here, and if these are two parallel lines and this line here bisects the lines, and so these angles are interior angles. So if this is 35, then this also has to be 35 just by geometry. And then we don't know this angle of T, but we're going to define it with respect to the positive x-axis counterclockwise. Then once we find that, we'll go back and figure out what this angle is here. So T2 is equal to, has a value of T2 at theta 2. Okay, so those are our three vectors. We know that those vectors are in static equilibrium, so they have to add up to 0. This is our unknown here, actually. So I'm going to put my unknown right here. Instead of re-recording this whole thing, I'm just going to move my U. Okay, so here's the unknown, T2. I need to know the magnitude and the direction. So my equation, well, second law, sigma F equals mass times acceleration. It's in equilibrium, therefore mass times acceleration is equal to 0. So we then go to our x-axis, and we have sigma Fx is going to be equal to mass times acceleration in the x direction, but it's also equal to all of our vectors added up. So I'm going to find all the components in the x direction. So I'm going to do the long way here. T1 cosine of theta T1 plus T2 cosine of theta T2 plus W cosine of theta W equals 0. Okay. So right off the bat, if I put the numbers in, I've got T1 cosine of theta T1, so I have 800 newtons times the cosine of 35 degrees plus T2 cosine of theta T2 plus the weight, which is 638 newtons, times the cosine of 270 degrees. Many of you already know what that is. All right? So if I go ahead and find my values, I have 800 times the cosine of 35, which is 655.3 newtons, plus T2 cosine of theta T2 plus 638 times the cosine of 270. Cosine of 270 is 0, so this is 0 equals 0. So we can solve for either one of our values. In this case, it's a little bit easier. Subtract 655.3 from both sides. I get T2 cosine of theta T2 is equal to minus 655.3 newtons. And then we can divide both sides by cosine theta T2, and you end up with T2 is equal to minus 655.3 newtons divided by the cosine of theta T2. Okay, so obviously we can't solve this because we have one equation and we've got two unknowns. We don't know T2 and we don't know theta T2. So we need to find another equation. In math, if you have two unknowns, you need at least two equations to solve. Well, we have another axis, right? We have sigma Fy. And that literally is going to be this same equation, but we have sines instead of cosines. So we'll have T1 sine of theta T1 plus T2 sine of theta T2 plus W sine of theta W equals 0. And we just plug in the numbers. 800 newtons times the sine of 35 degrees plus T2 sine of theta T2 plus 638 times the sine of 270 degrees equals 0. So 800 times the sine of 35 is equal to 458.9 newtons plus T2 sine theta T2 plus 638 times the sine of 270. Well, the sine of 270 is negative 1. Negative 1 times 638 is minus 638 newtons, 0. So let's move the constants over to the other side. So we're going to add 638 to both sides, and we're going to subtract 458.9 from both sides. And if you do that, you get 638 minus 458.9, and I've got T2 sine theta T2 is equal to 179.1 newtons. Okay, I'm then going to come over here and I'm going to substitute into this. So I'm going to substitute negative 655.3 newtons divided by cosine of theta T2 for T2. And I get minus 655.3 newtons divided by the cosine of theta T2 times the sine of theta T2 equals 179.1. Okay. So if we look at this in terms of multiplying fractions,